In this video, we'll examine how constructivism can be used to improve students' critical thinking skills. Critical thinking requires students to engage in evidence-based thinking. Traditionally, this means building their skills in collecting, analyzing, and evaluating evidence. However, historical and recent events illustrate that it is vital that students also know how to detect intentionally manipulated data. Data manipulation has been central at creating division and strife in our societies, and it has been a tool for exploiting individuals. But recently, mass media has exacerbated the opportunity to use manipulated data as a tool for controlling people's opinions and actions, so we must equip our students with the tools to defend against this manipulation. Constructivism is one of the most effective pedagogical strategies to help students develop these skills. In constructivism, students engage in a task that presents them with data that is likely to contradict their mental models. This contradiction creates cognitive dissonance, in which students are encouraged to re-evaluate their beliefs, assumptions, and biases that have been used to construct their mental models. Unfortunately, this is not an easy process. Our instincts as humans is to protect and defend our beliefs and mental models, and so even when data contradicts the model, we are tempted to dismiss it as an anomaly and to succumb to confirmation bias practices where we seek cherry-pick data in order to preserve our beliefs. Consequently, even though constructivism works, it rarely succeeds through a single learning event, but through a series of events that repeatedly creates cognitive dissonance around the belief. In other words, misconceptions and biases take time to eliminate and therefore require repeated attack through constructivist episodes that create growing cognitive dissonance over time. To illustrate how constructivism can be used to create cognitive dissonance and target misconceptions that are commonly exploited by manipulated data, we will look at an inquiry for grade 11 biology. In this inquiry, we are exploring the evolution of humans via a skull analysis. Due to COVID, this inquiry was modified for delivery in a virtual classroom. The misconception that we tried to target in the inquiry was the idea that humans are divided into biologically distinct racial groupings that can be identified by variations in their physical characteristics. As with most misconceptions, this idea is upheld by real observations that fit a narrative supported by everyday experiences of students. So for instance, it is true that we can often guess the ethnic group of a person from their external features, but this is not because these groups are genetically distinct. All humans are descended from humans who evolved in Africa. However, as small populations of humans migrated out of Africa in waves, they experienced a genetic bottleneck because as small populations, they represented only a subset of the African gene pool. Added to that, natural selection due to environmental conditions in their new environment shifted the frequencies of the various genes in their gene pool as they settled. Finally, interbreeding with closely related species outside of Africa did introduce a handful of genes to these populations. These non-Homo sapien genes did make their way back to Africa, but only after migration between the disconnected gene pools was restored over time. Consequently, the differences between human gene pools is not due to a genetic difference, but the degree of variation they have maintained from the original African gene pool. That's why we humans have the same genes, but the people of Africa show more variation in these genes, and therefore Africans look very different from each other, whereas populations from outside of Africa have a narrower degree of variation and tend to look more similar within their specific groups. This shift in variation does not mean that we are biologically different, but it allows the narrative of biological races to persist. And this narrative has been and continues to be exploited by data manipulation by those who wish to preserve the benefits that the narrative gives to them. So how do we target a false narrative that has stood the test of centuries? First, we started the lab with a simple exercise to expose students' thinking. Students were given the above image. They were told it was published in a scientific book around the turn of the 20th century. They were asked to answer the question, is this image racist? Their instructions were to answer on a Jamboard without discussion and to focus on why they were choosing their appropriate response. 2 students thought that the image was racist because it used a single person to illustrate a race and it was therefore stereotyping. And one of these students was also concerned with the choice of the labels that was used under the images. One student felt that it was not racist because the images are someone's personal perspective and their own observations. But most students were unsure. The core thread in the confusion is a desire to know more about the intent of the artist. Most students seem to think that the intent of the artist is the central data point they require to determine whether the image is racist or not. So then we left the opinions alone and conducted our inquiry. The first task was for students to analyze an evolution tree for hominids to determine who the closest and the second closest relatives to humans were. Students were able to establish that our closest relatives were Neanderthals and Denisovians. They also illustrated the ability to detect that humans outside of Africa had interbred with these relatives. Most students, although not all, also recognize that our second closest relative appears to be Homo erectus. In our second task, students were asked to compare and contrast the skulls of our closest relative, Neanderthals. We did not compare Denisovians because we have yet to discover skulls for these hominids. Students recognized that the skulls differed from each other in key ways. Neanderthal had a bigger brain and was disproportionately larger at the back, but Neanderthals had a smaller forehead and they also had larger jaws. Once we had analyzed the differences, we conducted a discussion on the significance of these differences. To support this discussion, we Googled a few labeled images of human brain structure and function. After our exploration of Neanderthal and Homo sapiens, we re-examined our pre-lab question a second time. Students were provided with an image of human and Neanderthal skulls, this time with the original image, and asked to reflect on their learning when they re-evaluated the pre-lab image. Now only one student felt unsure. They were still holding intent as their central to their decision-making process. However, the number of students who opted for no is now larger. This is actually a good sign, even though it might not seem so at first. These students reflect that they are experiencing cognitive dissonance and are trying to defend their belief. They are trying to justify holding on to the belief that is under attack. They can name the belief, and they claim it as a fact in order to dismiss the conclusion that the data is suggesting to them. They claim that the image is just illustrating the differences among us, and so if that is true, the image cannot be seen as racist. Interestingly, look at the starred comment on the screen. This student has actually copied and pasted their answer from the pre-lab. This suggests that they're avoiding engaging in the thinking process, which is a classic strategy that humans use to protect their attacked beliefs. But it's still progress because they recognize the belief is being attacked by the data. Once cognitive dissonance has been experienced, the flawed belief is under attack, and time and repeated events with data will complete the process. We cannot expect this to be an instantaneous process. Finally, 5 students now recognize the true reason that the image is racist. The person labeled as Negro has a Neanderthal skull. The one labeled as Irish Iberian has a skull that combines features of Homo sapien and Neanderthal. And finally, the person labeled Anglo-Teutonic has a Homo sapien skull, but the forehead has clearly been enlarged. These 5 students not only recognized the lie in the image, but were able to argue how this lie contradicts the additional data that was provided in the hominid evolution tree. These students' explanation served to add to the uncomfortable cognitive dissonance that would be experienced by the others. Finally, to satisfy the need for context that one student still feels, I added the context by displaying the caption that came with this image. The caption literally backs the 5 students who said that the image was racist, and it adds the reason for the narrative. The narrative explains why the author thinks that a healthy struggle between these groups is justified and that there is expected a domination of 2 of the groups by the group labeled Anglo-Teutonic. We ended the lesson with a quick diagnostic activity. Could my class explain what is wrong with this image? I did need to explain to them that Cro-Magnon was a Homo sapien group from the region of France. Once that was defined for them, they were able to not only articulate the central lies of this image, but the narrative that it upheld. For the record, I do not know the original source of this image, but it came up repeatedly in my search for images to use with this lesson. So clearly, this is a narrative that is still being pushed today. Links to my files associated with this task are in the video description below. Feel free to download these files and use it. If you're an educator, please consider subscribing to this channel. My hope is my videos are useful to you and help me to consolidate and reflect on my practice. And if you are an educator, good luck in your journey. We are all in this together.